Types of software testing. Today, I am going to present the types of software testing rather than list out the people to test. I will focus on four questions when testing is done. Where is testing done? The aspects of quality are tested and how test ideas are generated. Then I'll use those ideas as an example of an e-commerce checkout. The structure is based on ISTQB foundation level syllabus with the specialist examples following OWASP and WCAG guidance. At the end of the presentation, we should be able to tie a test objective to an appropriate level, type, technique, and form of evidence. Why testing needs a map? Testing helps in making the decision regarding quality and release risk. While a system may perform a functional function correctly, it can be too slow, insecure, or inaccessible or unreliable. It can also enable a new feature test while an old feature is broken by the change. That's why it's important that a useful test clearly communicates its purpose, aim, and expected finding. The four book cards display the four key questions. Does the product work? How well does the product work? Is it safe to change products? Is the product ready for use? Combined, testing can be used to prevent defects by providing early review, detect defects through execution, and provide objective evidence to inform stakeholders. One product, four ways to classify testing. This is a main map for the presentation. The first classification is when testing occurs. Static testing looks at work products but not running software. Dynamic testing runs the software. The second one concerns the size of the test, ranging from a small part acceptance of the entire product. The third question, what qualities are being studied, particularly functional or non-functional qualities. The fourth chapter asked, where do test cases come from specification, from internal structure, from experience. These classifications overlap. For instance, a security regression test can be dynamic, system level, non-functional, and black box. Testing taxonomy. The same ideas are rearranged as a hierarchy in this diagram. There are four types of software testing. The separation of static dynamic testing is achieved by execution. The five scopes from component through acceptance are shown as test level. Quality objective involves functional, non-functional, and change-related testing. Technique indicates if tests are built from specs or from internal structure experience of the tester. The branches should not be interpreted as mutually exclusive options. A real test can consist of a combination of one item from a number of branches. For instance, a system-level regression test can be dynamic, functional, blackboard. The combination can be described precisely with the taxonomy. Static and dynamic testing complement each other. Static testing is a testing method that is not run on software. It involves reviewing requirements, designs, user stories, test cases, and source code, and also has tool-supported static analysis. It is especially beneficial when used to detect ambiguity, consistency, unreachable code, and missing acceptance criteria. Dynamic testing is the execution of the test object and comparison of the observed behavior with expected behavior. It can show failures, state changes, timing, and resource problems. Both methods are not mutually exclusive. A good team might investigate checkout rules for ambiguous discounts and carry out functional and performance testing. Following the implementation, the combination captures various categories of defects and offers feedback at an early stage. 5 test levels. Scope expands with each layer. ISTQB foundation level lists 5 levels of testing. Component testing is a testing method that tests one unit of the component in isolation and is typically done by the developers. Component integration testing tests interfaces and interactions between components. System testing tests the entire product, end-to-end behavior and quality characteristics. System integration testing is directed towards the interfaces with other external systems or services like payment gateway, etc. Acceptance testing shows the business value and readiness for deployment, preferably with the intended users or relevant stakeholders in the iterative development process. The levels may overlap. Also, there may be multiple instances of the same type of test. Security and performance work shouldn't be reserved until the full system is in place. Functional testing. What the system does. A functional test is one that is used to test what a component or system is supposed to do. The three objectives shown here are completeness, correctness, and appropriateness. The checkout requirements provides a tangible test case. The displayed total should be the sum of subtotal, delivery, discount, and tax, and the amount charged should match the total. The table turns the rule into specific test ideas, including valid and expired discounts, payment success, and payment decline. Note that there is evidence for each test, not an ambiguous test to check the page. Good functional tests go back to the requirements or acceptance criteria and contain normal cases, invalid cases, and important boundaries. Non-functional testing. how well it behaves. Non-functional testing evaluates how well the system behaves. The slide lists the quality characteristics. Non-functional tests are the ones that test the manner in which the system behaves. The quality characteristics mentioned in the slide are taken from the ISTQB syllabus: performance, efficiency, compatibility, usability, reliability, security, maintainability, portability, or flexibility, safety. These qualities need to be measured with constraints. Fast is not a strong word to use for checkout. Performance requirements should be specified or workload and a threshold for response time. The statement should be accessible is also incomplete because the team should have testable criteria, let's say keyboard operation, an obvious focus, and a label control. Functional and non-functional testing are complementary. Checkout should not only pass, but should also pass with a quality goal. Change-related testing, fix it, then protect it. Two separate checks are required following a defect, fix enhancement. Confirmation testing is to determine if the original fault has been corrected. Test steps that reveal that the failure are generally repeated and a targeted test of the new logic is performed. The question is of regression testing is, did the change have a negative impact or other areas? The impact analysis can be used to determine the impact on components, integration, environments, and user journeys. Regression suits tend to increase when the product changes and as a result are good candidates for automation. The order on the slide isn't arbitrary. Confirm the fix, analysis, the impact, run the appropriate regression scope, and then give release evidence. Black box, white box, and experience-based lenses. Here are three lenses for thinking about the origins of test ideas. Black box techniques are based on specifications and an externally visible behavior. These include equivalence, partitioning, boundaries, value analysis, decision tables, and state transition testing. White box based on internal construction and measure coverage. Experience-based methods are based on the test experience, incident history, and exploration, such as error guessing, exploratory testing, and checklist-based testing. They are complementary. A decision table can be used to test combinations of rules for a discount feature. Branch coverage can be used to show where code is not being executed, and exploration can be used to try out some unusual combinations not specified in the specification. Testing pyramid. The testing pyramid illustrates the typical structure of a well-balanced automated test portfolio. The component test represents the wider base since they are focused fast and can be close to the code. Tests for interactions between the units are called components. Integration tests, systems, and system integration tests wider behavior and outer relationships. Acceptance tests are at the highest level and demonstrate business readiness. The diagram does not specify percentages. It focuses on the message that there shall not be reliance solely on end-to-end tests, which are slow and broad. The higher layers shield entire workflow and the needs of the stakeholders, and the lower layers provide for faster diagnosis. Security, accessibility, and performance. This slide illustrates the specialist test aspects which transform a general quality concern into risk checks and evidence. Security testing can involve checking authentication, authorization, input validation, session, and configuration. And the results can be cataloged by impacted asset, impact, and mitigation. Accessibility testing involves some automated testing and a manual review to check for keyboard navigation tracking, visible focus, label, contrast, and error handling, and alternatives using WCAG success criteria as a reference. Performance testing is done with a realistic workload and explicit threshold, and it will report percentile of response times throughout error rate and resource behavior. In each case, a tool result can only ever be useful if it is linked to a risk and interpreted in its context. Manual and automated testing assigned by value. Automation is a way of doing, not a test objective per se. Tests are good candidates for automation when they run often, have objective results, and have fairly stable interfaces. This is frequently the case for units, API, smoke, and regression checks when observation, judgment, and learning are important, such as exploratory usability work. Human-led testing is important. Some high-risk scenarios require both. Automation provides repeatedly feedback and a person investigates unexpected behavior. The maintenance, cost, data, environment, and durability are all covered in the checklist on the right. When an unstable low-value check is automated, it can lead to increase in work. Software testing lifecycle. This is software testing lifecycle. Requirements analysis is used to find out the test basis, risk, and testable conditions. Test planning specifies scope, approach, resources, and completion criteria. Test design yields test cases, data and coverage, environment setup, Systems and tools are prepared for execution. Test execution stores information about results and defects. Test closure assess completion, record lessons learned, and report risk. Feedback and improvement are at the heart of it, as information from any stage could require an earlier activity to be refined. It is thus an iterative process and not a one-way checklist. Example strategy e-commerce checkout. In this instance, ideas are woven together into a single layered approach. Cart calculations start at component level. Component level pricing interactions are validated with the decision table for discount tax combination. All the supports of the checkout process are verified at system level security resilience scenario. System integration tests have been performed for the payment gateway. Acceptance is achieved by involving intended users and operational stakeholders. We also take a look at performance, security, accessibility, compatibility, and regression at all levels. Choose the right test by asking the right question. This table serves as a useful selection guide. If something is not clear, start with a static review. Use functional and black box testing if the question relates to required behaviors. Add white box coverage if necessary to support important code structure. If the concern is a quality constraint, then use the appropriate non-functional test with quantifiable thresholds. Confirmation is provided after a fix, ensuring that the problem reported in the initial test is resolved. Regression is performed to ensure that no other behaviors have been changed. Acceptance testing aids the development decision. The message is that picking the right tool is last. Decide on the objective, risk, scope, technique, and evidence first, and then select the tool to assist in the plan. Revision questions and sample answers. The difference between static and dynamic testing is to be answered in question 1. Static testing is analysis of work products without running the software, and dynamic testing is running of the software and comparing an expected to actual behavior. Question 2, select the 5 test levels: component integration, system integration, and acceptance. These shift away from screening one product towards assessing business readiness for the whole product. This question is comparison of functional and non-functional testing. Question 3, functional testing. It verifies the functionality of what the system should do. Non-functional testing, it evaluates the system's behavior, including its performance. Question 4, after fixing a defect, why do you need to do a confirmation and regression test? A confirmation is to rerun the original failing scenario to verify the fix, and a regression is to ensure that existing behavior in related and affected areas is not broken. Question 5 refers to the use of automated testing and human-led testing. Human-led testing and when it should be used. Automation is good for repetitive test scenarios where there is a correct answer. When observation, judgment, and learning is required, such as exploratory usability testing, human-led testing is more suitable. The following 5 revision questions and examples answers are also provided in the supporting documents. Key takeaways and references shelf. Finally, test levels provide information on where testing is happening, and test types provide information on what quality objective is being tested. Static testing is used in conjunction with dynamic testing. There's a close relationship between confirmation and regression, but they answer different questions. While automation is useful for repeatable checks, nothing can replace human judgment when learning and evaluating. 3 references to the right support uh, the presentation. ISTQB is for the core testing framework, OWASP is for web security testing, and WCAG 2.0 is accessibility criteria. I'm going to end with one decision question, which tests when time is scarce, making the most contribution to protecting product and business risks. This is the end of the presentation.